Good afternoon to all, and welcome to today's ITS Canada 2020 Supplier webinar series. This is the 5th webinar in the series, and I welcome you all. My name is Janneke, and I am the Managing Director of ITS Canada. Today, I want to start off with a poem. Today, we are being joined by 4 members: International Road Dynamics, Iteris Inc., Cellint, and Global Traffic Technologies, who each will share their new initiatives, products or services to aid the industry in response to the COVID-19 pandemic. Each company will be given 10 minutes, followed by a 5-minute Q&A. And if you have any questions, please leave them in the question pane. And after each presentation, I will share those questions with the presenter. First will be François Blouin. François joined IRD in April 2020 as Chief Technology Officer, leading the integration, enhancement, and development of next-generation ITS. François received his electrical engineering degree from Laval University and has 25 years of experience building strong, unique, and ambitious teams, creating leading-edge products, establishing deeply informed and disciplined technology product roadmaps. Known for realization of bold and pragmatic innovation strategies in 4 industries: information and communication technology, transportation, and energy. Prior to joining IRD, François led ATCO Innovation Practice in the Electricity Global Business Unit, where his focus was on utility of the future, electrification of transportation, and smart grid data platforms. François was awarded Prolific Inventor for contributing to Nortel's intellectual property with 20 combined patents and filings in the area of high-performance networking, wireless technologies, real-time system design, quality of experience, and user-centered design methodologies. And with that, I am going to make François the presenter.
I'm very proud to be a new member of IRD organizations, now 6 weeks. And I'm looking forward to bring the ITS Canada and IRD to the next level. And I'm very happy to be on board. And also, I'm looking forward to bring a bit of a French culture touch in Western Canada. Et j'ai bien hâte de travailler avec vous tous et au plaisir de vous voir en personne prochainement. In terms of agenda, I'd like to spend a couple minutes on some of the trends and disruptions that we see in our industry coming up, and in fact, not only in our industries, but across multiple industries, things we need to pay attention. And I'll be pleased to introduce some new solutions that IRD is just releasing to the market, ITHEA and CDMS, and entertain questions and answers thereafter. For those of you who are not familiar with IRD, International Road Dynamics, we are a technology manufacturer, systems integrator, and solutions provider. And we've been involved in the ITS industry for more than 40 years. We are headquartered in sunny Saskatchewan with offices in operations in Canada, USA, and worldwide. Our specialty is in way in motion, commercial vehicle enforcement systems, traffic data collection, traffic management systems, bringing security to highways, port, borders, and other critical infrastructure. The trends and disruptions that are affecting many industries are summarized here. Our customers are now in a very digital mindset. They have access to data, in fact, rich data, and they're expecting us to be the same by providing them anytime, anywhere, information, analytics at their fingertips. So this is one area that we are focusing on and we'll need to pay attention in more in the future. The world is also evolving towards what I would call a hyper-connectivity. Everything is connected, everything is talking to each other, systems, human, people, businesses, sensors. How do we connect everything in a efficient and low cost, and how do we aggregate all this information in single platforms? That will be one of the topics of the product we're going to be announcing in a minute. A number of exponential technologies are coming up, like AI, think about autonomous vehicles, artificial intelligence. These technologies are increasing the computing power, their price and cost is reducing every year. They're accelerating and very fast. And last but not least, economic models such as the sharing economy, e-commerce, supply chains are affected, and the role of aggregator in the future will become predominant. A couple of words on the artificial intelligence, and I don't plan to do a thesis here, but I just wanted you to be aware that I typically divide the field of artificial intelligence into two main areas. One is what I would say algorithm-based or programming. So this is more the original computing science, where you program an algorithm and it makes decisions. So expert systems, fuzzy logic, and robotics are leveraging that kind of more traditional algorithm design based. The area that came up more recently is statistical base, where you don't necessarily write a program or logics because it would be too complicated to write all the different combinations. Instead, you train a AI engine or a machine learning engine to learn and recognize pattern. The product that we're releasing today, ITHEA, is leveraging this machine learning concept where we have trained an AI engine to recognize patterns, and it leverages a video-based camera system to allow traffic counting and classification. We are also able to measure the vehicle speed, the number of vehicle, and up to 13 class of vehicles are now recognized. So the benefit of such system is obviously it's non-intrusive, so we don't need to do civil work here. It's ease of installation, and it's learning. So that means it could be improved. It could detect more types of vehicle as the world evolves, for instance, to electrification of fleets, for example. So how it works is as I briefly discussed. So the live camera video feed is injected into our AI engine, and basically the training data, we took around 3 years of data, video from different highways and tolls, And now we're doing a pattern recognition or pattern matching in real time to provide the detection of the system or the classification of the vehicle. We have validated it under a number of operating conditions, sunlight and up to snow and low visibility fog. And the system keeps learning. So we're going to be retraining that system on a regular basis to adapt to new environmental conditions. The second product that I wanted to bring to your attention is called Centralized or Central Data Management System, or also referred as CDMS. Essentially, here we're applying one of the new needs of integrating, aggregating data from multiple sources. So again, as we evolve towards a hyper-connected world, we anticipate the needs to now connect multiple sites, different types of infrastructure, and consolidate this information in one centralized location. We have chosen to approach this using a cloud-based infrastructure to allow us to rapidly being able to scale, expand, and generate a number of new analytics reports. The architecture of the system is defined here. Essentially, we have designed a real-time interface to connect a variety of infrastructures, whether they're traditional waiting motion stations, e-screening, physical, and even virtual wait station. So we're now able to integrate and aggregate this a variety of systems into a centralized repository. We also have the ability to do quality check on data and produce a number of dashboards and analytics for reporting. So this is one example here of a system that is being deployed and now under test at one of our customers. So we can now quickly at a glance have notifications, alerts, detections on thresholds, number of vehicle, and a number of statistics that we can adjust or create or program as needed. And at a fingertip, having a KPI dashboard to allow enforcement and detection. In the recent, I guess, weeks or month with the pandemic, we have decided to run and test our system and analyzing the traffic patterns that we see in one of the states that we've deployed the system. And what you see here is on the top graph, you see a trend downwards on the volume of traffic for different classes of vehicles. And as expected, it is going down, and hopefully it's going to go back soon. But this is a kind of analysis and reporting that the system does, along with a variety of statistics and search and to do some different configurations or combinations at a broader scale beyond a single site, but at the aggregate level. In summary, we see the benefits of CDMS as a more effective way to manage large data sets, integrations with multiple infrastructure sites. And we're looking here at the data at the enterprise level. And we can set up different KPI thresholds for alerts and notification. And at the end of the day, it provides, because now we are able to correlate multiple sources of data, it provides a new set of insights and information to help make decisions. So in closing, I'd like to share with you some of the thoughts. Again, the world is moving at an exponential pace. We see coming up sooner than later autonomous fleets. We see electrification of transportation. What would be the impact now if now the electric trucks are starting to be deployed and their battery pack is probably the size of a cargo at this point? How the roads will handle that? Blockchain security to maybe as a way to secure all the information and be able to now provide access to a wider variety of information. The hyperconnectivity, 5Gs and IoT is coming up that will also provide and enable the connected vehicle and connection to infrastructure. I look forward to collaborate with ITS Canada and contribute to the ecosystems of suppliers, partners, and customers. And I look forward to work with you all, and feel free to reach out to me if you want to continue this dialogue. I welcome your feedback, and thanks for your time and opportunity today. Then we can do a Q&A now.
Thank you, François. Merci beaucoup. I have a question. The customers, you shared their examples with them. Do they have remote access to the data since everybody is working from our teleworking?
Yeah, the system that we've developed is cloud-based, and we have created a number of web access and web reports. So the answer is yes, and that's a very good question. How do we now make the data and information now available on different platforms? So we've decided to invest in a cloud-based platform to allow flexibility to enable our customers, now that in their changing work behavior, to have access into a wider range of access facilities beyond going on the physical site.
Thank you. And my next question is, you talked about the electrification of trucks. What about the role of truck platooning in this? Is there any or not?
The role of what?
Truck platooning.
So yeah, so the truck platooning will become, obviously, it's been tested in different states now. This is basically combining very precise autonomous capabilities and electrification together. And now the question would be, if you have a fleet of 5 trucks with one driver, or maybe eventually no driver, how do we manage the who gets the fine? Is it the robot or the firm? So that will bring some interesting questions. And how do you do inspections when you have platooning? I don't have yet the answer of that, but I truly believe in autonomous cars and autonomous vehicles. So it's an emerging field that would create different, I guess, behavior on the logistics and operations and some ethical aspect as well. So I'm not sure I have the answer to your question, but that's certainly something that we need to pay attention moving forward.
Yep. Thank you very much. That was it. Thank you very much, François.
Merci.
Next up is Iteris. There's 2 presenters. First is Ms. Vandervalk-Ostrander, PE, PMP, who serves as the Vice President of Business Development for Iteris Transportation Systems Division. She has extensive experience managing transportation programs and projects in the disciplines of planning, engineering, TSM and Artismo, ITS, and data management. She is nationally recognized for her research and application of transportation data governance across the country. She's past chair of TRB's Statewide Data and Information Systems Committee, past president of ITS Florida, and currently serves as president of Women in Transportation Seminar, WTS, in Tallahassee, Florida. She's got a BS in Civil Engineering from Queen's University in Kingston, Ontario. Second presenter is Dr. Masoud Hamedi, who is a senior manager with Iteris, responsible for business development and client management in the transportation analytics space. He works closely with the development team, clients, and marketing to make sure that Iteris data analytic products continue to grow and stay competitive in the industry. Before joining Iteris, he was with the Center for Advanced Transportation Technology, CATT, at the University of Maryland, where he managed data validation program for the National Performance Management Research Dataset, NPMRDS. And with that, I am going to hand over the screen to Anita. Anita, over to you.
Good afternoon. Thank you, everyone. Yannicka, can you see my slides?
talking to myself. No, I can see your an email inbox or a calendar invite.
All right, hang on. Sorry about that. How about now?
Nope.
All right, hold on a second here. And now.
Yes.
Perfect, thank you. Sorry about that. Thank you so much to ITS Canada for giving us at Iteris the opportunity to present to you this afternoon. As Jannica mentioned, Masoud and I will be sharing the podium here. I am going to give a brief introduction to Iteris and to the tool that we want to talk about today, which is called ClearGuide. Iteris's vision is to be the global leader in applied informatics for transportation. We are located, our headquarters is in Santa Ana, California, with offices all over the United States, and we are proud to have as our distributor in Canada, GGI, who I have presentation or contact information at the end of this presentation for GGI. What Iteris does is a combination of detection and communication hardware, including advanced video and radar detection capabilities. We have a variety of tools for identifying and locating cyclists and pedestrians, for example. In the middle of our screen, we talk about our software products. We have products for performance measures, analytics, and commercial vehicle operation. We have a very advanced signal performance measures or SPM product, but today we're going to talk about our traffic data analytics platform called ClearGuide. And we accompany these software products and our detection and hardware with a variety of excellent consulting services, including mobility and analytics, 511, ITS engineering, technology, data planning, all of which helps our clients become smart communities. We have over 20 years of experience working with agencies nationwide, that's in the US and abroad in Canada, including a ClearGuide deployment of for Transport Canada and one also for the City of Toronto. So you can see on this slide the variety of clients that we service. We're proud of our pioneering approach to technology. This graphic shows a number of number ones that we've had over the last several years, including the first in the industry to have bicycle detection and integrated pedestrian counting, and a comprehensive software as a service traffic analysis system, which we'll talk about here. As we know today, and François touched on this, with the changes that we see coming, we see even more available data, whether it's from IoT devices or growing private and public sector traffic of data allows us to have a variety of data. And it really often brings us the question of how do we bring all this data together in one visualization engine that allows us to really drive decision making. And ClearGuide is designed to do that. It's designed based on over 20 years of information and data science to bring together data for performance measures, real-time operations, and for transportation planning. ClearGuide has been, as I said, has a long history. It's used for over 25 clients across Canada and in the US. And it really allows for the bringing together of data in a real-time contextual mobility intelligence platform. As you can see by the graphic on the screen, and it appears that it's not moving. Maybe you're supposed to see that weather moving, but what's interesting is you're able to see a variety of different data sources, the primary of which is third-party probe data. And in this case, for ClearGuide, the instance we're going to talk about is powered by HERE Technologies, which is the source of the speed data. But what you're able to do is see speed data at a very high resolution in real time compared to other data sources. In this case, we're seeing weather. You can also bring incident data to the table, traffic volume data, and any other variety of data that the client has available. So who uses ClearGuide? ClearGuide is a scalable solution. It's a cloud-hosted, web-based analytics and visualization tool. Like I said, that processes data from a variety of sources, and it's very scalable to meet the needs either at a national level, as we do for Transport Canada, or at a county level, MPO, city, corridor level. And I am going to turn it over to Masoud here in a moment. Just a couple of examples of some of the things that we can use cases for ClearGuide. We use it in an operational setting to do integrated corridor management, incident management, before and after analysis. And it's notable to say that we can use ClearGuide on both arterials and freeway systems. Couple of differentiators is our sound industry leading data science. I mentioned that we are cloud hosted and web-based. And I'm going to quickly get over to our analytics that Masoud has conducted to show you the impacts of the pandemic and how ClearGuide can help you to do that. Masoud?
Thank you, Anita, and thanks, ITS Canada, for the opportunity. So I'm going to use this short time to show you how we can capture the impact of the COVID-19 pandemic-related policies on the traffic patterns on the Toronto's network. As Anita mentioned, this particular ClearGuide instance is powered by the HERE data. There's a whole host of tools in the ClearGuide. We're going to be using a handful of them: the regional mobility dashboard, the monthly speed contours, time of the graphs, and the trend maps, and route time comparison to answer questions like how much the congestion changed during the past few months, what was the biggest change, was the impact similar during morning and afternoon, and are there any insights into your arterials? Next, please. Okay, so let's look at the 18-kilometer stretch of the Gardiner Expressway in Toronto. This is a heavily congested corridor in both morning and afternoon with unreliable travel times. You can see like a typical daily contour plot at the bottom. Next one, please. So if I pull a monthly corridor of a monthly contour of the speeds of this corridor, you can see that you see your typical morning and afternoon congestion. The blackest spots on the contours are where the roads are closed. But on the 17th, you see that when the shelter-in-place order is issued, the traffic patterns changed and the congestion almost goes away overnight. Next, please. Okay, so we can do travel time comparison for the before and after. Let's look at the first 2 weeks of March 2020 and the third and fourth week of March 2020 for the weekdays. As you can see, this is a average travel time on this corridor, and there is a huge reduction in the travel time. On the peak, it has been 13.5 minutes. It's down to the regular 13 minutes, so 20-minute reduction. And the same thing for the afternoon. This is the eastbound direction. Next slide, please. Okay, so on the arterials, I picked the 6 kilometer of the Yonge Street between Sheppard and Eglinton, and that's the typical congestion pattern of that corridor. You can see that there is more breadth when there is a higher density of the signals. But when you pull the time series for the 3 months from the February onwards, you can see that the hourly average speeds change and travel times drop and kind of are following a flat pattern. Next one, please. If I look at the northbound and southbound of that corridor, or the arterial corridor, you can see that on the northbound you have 2 peaks, morning and afternoon. On the southbound, the afternoon peak is not that big, but this is the graph of the delay during the times of the day for those 2 time periods, and you can see the difference that the policies of shelter in place have made. Next one, please. I ran this for a bunch of other freeways and arterials, and there are some takeaways here. The average percent speed increase has been higher on the freeways, and on the downtown arterials, we see a lower speed increase compared to the more major arterials. So you can compare a bunch of corridors together using ClearGuide tools. Next one, please. If you want to look at the trend of the region, I can aggregate all the data for the Toronto region, and you can see that for the month of April, for both morning and afternoon peak periods, the traffic congestion has reached the lowest ever historical. We can do this on different sub-regions and for different performance measures. Next one, please. If we wonder where the congestion changes, we can have long-term trends that aggregate the travel time reliability and congestion measures, and you can see them visually on the network. This is for the month of February, 8 a.m. Next one, please. And this is month of April, the same peak hour. And you can see that there are still a bunch of red spots on the map. Those means that even when the traffic is gone, there is some reliability issues happening. So maybe they need to be investigated. But this is just an example. There are other measures that can be picked, and you can do this, customize it on different zoom levels, on different roadway classes. So at the link level, at the corridor level, at the regional level, we can capture the impact that the COVID-19 shelter in place have had on the Toronto's network. Next one, please. Yeah, and that's all we got at this short time. Our contact information is on the slide. Please feel free to reach out if you have more questions. Thank you.
They're exactly 10 minutes. Thank you, Masoud and Anita. I have a question. So for the City of Toronto, I guess end user, for those who are teleworking, can they access this data remotely?
Yes, ClearGuide is made on the Amazon Web Services platform and is available wherever you have a web connection available.
Okay. And can ClearGuide be applied or used all over the world? I think Anita in her introduction mentioned nationwide, so it's being deployed in Canada and the US, but let's say that there's a European city that would be interested in ClearGuide. Can it be applied or elsewhere outside of the North American continent?
Yes, ClearGuide is a vendor agnostic platform, so it can ingest probe data from any data vendor. Our strategic partner is here, and here has data almost worldwide. So wherever they have data, we can instantaneously turn on this solution. For the case of the Canada, we even have customized it. Transport Canada has the coverage on the network of Canada and 5-kilometer buffer into the United States. So the answer is yes, and it's even more configurable.
Okay, thank you. And I think also Anita mentioned in her slides, emergency operations. Have you seen an increase due to the pandemic of COVID-19, that there is an interest in ClearGuide by those cities who have created these emergency operation centers because of the COVID-19 pandemic?
There was no congestion during the COVID-19 pandemic. But there were other issues that they found additional use cases for the operations in ClearGuide. And I give you an example. They noticed that the speeds have gone up, both on arterials and freeways. So there was no congestion, but they were speeding, and the severity of crashes was going up. So we successfully used the ClearGuide to basically spot the locations that there were continuous high speeding, and they communicated that to the law enforcement to take measures. So it wasn't for the congestion, it was for the basically law enforcement.
Okay, thank you very much, Masoud and Anita. And we are now it's Bob's turn. Bob Pauley is the Director of Business Development North America for Cellint Mobility Solutions. Bob has been actively involved in the cellular-based data industry since 2010. Bob helps identify those data needs within the transportation industry and works closely with the software engineers who develop new speed, origin, destination, and positioning products to answer those needs. In fact, Bob sold the first cellular data-based origin destination study ever attempted in North America. With the onset of the COVID-19 virus in North America, Cellint is now using the real-time reporting technology cellular platform to help communities monitor their crowd and compliance issues and help save lives. Cellint sees all the phones connected to the Rogers cellular network completely passive to the handset operator with no EPPs, GPS, or Bluetooth turned on every 60 seconds in real time 24/7. We see all these cellular phones even when the cellular data is turned off to preserve voice communications by the carrier in a reserve or emergency. Cellint is connected to the Verizon network in the United States. And I am going to make Bob their presenter. Bob, over to you.
Hey. All right, can everybody hear me now?
Yes.
All right, I want to thank everybody for joining me today, and a little bit about Cellint. Cellint is originally a traffic products population analytics tool, and I'm going to go through this this presentation very, very quickly. Then I'm going to get to the COVID tools that we have. As Yannicka mentioned earlier, our system is absolutely passive to the handset owner. It requires no apps to be opened, no GPS on, Bluetooth on, or any other mechanism. The phone simply needs to be on and connected to the network. Cellint is integrated into the switching centers at Rogers Wireless in Canada and Verizon in the USA. And we see all the phones that are connected to the network in real time. We also take that same location information and archive it so we can go back and look at those same phones positioning on a historic basis. We get no subscriber information. Each handset is given a unique identifier, which is consistent over time, an ABC 123 number, if you will, and this allows us to do origin destination studies, or for that matter, speed, and the population analytics tools that we're going to be talking about. I'm going to go very briefly through this. This is really a traffic-oriented presentation, but we talked about road sensors and then cellular triangulation, GPS or app-driven location-based products. We obviously do the cellular triangulation. In Canada, we see approximately 30% of the population in real time through Rogers, and about 40% of the population in real time with Verizon. But a single antenna may cover 10 or 20 roads, so typically that's not accurate enough if you want to get real speed location on a particular highway. App-driven products or GPS-driven products are fine. The problem is they're not reporting enough locations in real time to give you a real accurate picture of what's going on. So as a result, they misdetect accidents or incidents on the road or slowdowns about half of the time. We have a proprietary technology that allows us to go out into a study area. We will record the control channel messaging in the background, listening to the network and with several phones, and record this with a high-grade GPS, upload it to our servers, and then when we connect to the switching centers, we can see the exact location of those phones, again, in real time. There's no other cellular-based technology that does this. Again, this is passive and requires nothing to be operated or manipulated on the phone. It doesn't need to be texting or talking. We rely upon the control channel messaging, which is the background information between the phones and the network that occurs automatically as you drive down the road. And we call this product Traffic Sense, real-time road management, speed detection, data analytics. These are all best in class, and I have a number of use cases that I can share with everybody. I'll be glad to send this presentation on to anybody that may have an interest afterwards. We have a live traffic dashboard, and we can also do a rerun visualization based on date. We also have a live traffic analytics, where people are coming from, where they're going. We have validation. So this was from the Seattle DOT, using our data compared with radar, Bluetooth, and other solutions and found us to be extremely accurate. Talking about origin destination, we all know about some of the problems with that. Field surveys, typically a very low sample size, sensor data, that's all hotspot oriented. And again, can be some frailties or maintenance issues around that. GPS data aggregators, relying upon the information that they pull off people navigating. Typically, most people are not navigating when they go to work or if they pick up the kids at school or go to the dry cleaners. So commuters are not typically well represented in that data. However, transients and tourists are. And then cellular network data that we typically use is very good for zone survey. But if you want to do exact positioning on the road, then we have to go back to the technology that Cellint uses in the background. By the way, we call that signatures. We're capable of doing origin destination studies from a small junction level to an entire country level. This gets into something that might be more COVID related. This is a population movements analytics tool that we developed. We're using it in Winnipeg. By overlapping our origin destination information along with our real-time traffic information, we can see every day where people are coming from, where they're going, and why are they stuck at 5 o'clock in the afternoon in that same place on the highway. With this particular tool, you can see who the contributors are, what neighborhoods are contributing to the congestion in the road, where they're coming from and where they're going. And this allows our planners to decide whether it's a mass transit problem, a road capacity problem, or some other kind of problem. But again, knowing where the people are actually coming from by postal code and where they're going and what roads they're traveling on gives you very powerful information for planning. This is a study we did for Metrolinx on a new rail station, not particularly relevant for what we're talking about today. And then this is a origin destination study that we did up in Edmonton, actually won a Ministry Innovation Award. Old City of Montreal, again, another origin destination study. And then a congestion route analysis, again, based on this, the signatures and the origin destination. And this was, again, a pie chart of what's going on with up in Winnipeg. We're also capable of doing counting stations, virtual counting stations on any particular roadway and telling you exactly what the traffic volumes are on that roadway without having any specialized equipment on the side of the road. And here's a study we did for North Central Texas Council of Governments, and a couple of other projects as well. Our tool has been used for economic development. And then this is a study in Belleville. Now I'm going to get to what we really came to see today. This is a project that we're doing in Seattle, in King County. And the problem was, here, let's move that control panel out of the way. The problem was that they wanted to understand how people were moving around the community. They could take our information and back it into long-term care facilities, which were a very, very hot area for the COVID-19, and also how people are complying with the compliance index, so to speak, how many people are venturing how far away from home. This dashboard is a live real-time report. We also have the ability to go back and look at prior dates and times. And we'll go ahead and see if we get this one to run here real quick. Loading data. All right, as we scroll in on this, each one of these squares right now is 64 square miles. And in that 64 square miles, we're seeing 144 visitors and no residents. So that would be, and actually it's not too surprising, that's out in the hills there in Seattle. But let's zoom in a little bit closer. Now we're down to 16 square miles, and we see that they have 637 visitors and 4 residents in that particular square. Obviously, not a high compliance ratio for stay at home. All right. Now we're down to 4 square miles. We see in this particular square there are over 1,000 visitors and 13 residents. Now we're going to move in even closer. Now we're down to 1 square mile, and in that square mile we see 77 visitors and no residents. All right, now we're down to 1/4 square mile, which is a fine resolution that they wanted in Seattle. And in that 1/4 square mile, which is basically 400 meters by 400 meters, you can see in this particular square there are 45 visitors and no residents. So everyone in that square don't happen to live there. I'm going to run a history report for the 6th. Do visitor count. All right, now it's loading the data, and it'll start at 6 o'clock in the morning. It's going to refresh every 15 minutes. But again, you can see the number of visitors and number of residents in a particular square. These colors, by the way, are customizable based upon what the customer wants to see. And then you can see how the squares turn from blue to red. In other words, there are more visitors that are entering in a particular zone or residents leaving. Now we're going to stop this and go to our compliance index.
Bob, you've got 30 seconds left, okay?
All right, and this is this is divided up by postal codes, and it gives us a compliance index for each of these postal codes, the number in the whole area, the number of people that are venturing in or out of 2 miles, and so forth and so on. And then we can get down to one particular postal code and go back. This platform is being run right now in Seattle, Washington, King County. We also have building a similar platform for Florida and South Carolina. I welcome any questions you might have.
Thank you, Bob, and sorry for rushing you at the end. When we did the practice run yesterday, I was amazed by the information available and what you showed. So is this information, real-time information, is that being used by the medical officer or medical director from the city of Seattle, for example?
Washington State Emergency Management.
Okay.
And they take the data and actually overlap it with hotspots or postal codes that are known to be COVID positive, based on hospital admissions and deaths. And now they get an idea of how people are moving around in the transmission of the disease. In the case of Florida, we're using the same platform, but their big concern is with the COVID outbreak. If they have a hurricane in June and they still have hotspots, whether they order an evacuation or a stay in place position for particular neighborhoods, because they don't want them on the road spreading a virus around.
Okay. Okay, and the data and the reports, people can access those remotely at the highest level?
Right. This is actually integrated in, so emergency management can use it as a real-time decision-making tool.
Okay.
See what's going on in certain neighborhoods. We've heard about COVID parties and things like that. This doesn't actually identify partygoers, but it does identify those neighborhoods that may not be in compliance, and then perhaps an information sort of thing. And then again, if you overlap it with hotspots, neighborhoods that may have a high number of senior citizens as residents or a vulnerable population, or they have a number of hospitalization of a neighborhood, then it allows them to see how people are migrating around what postal code to what postal code, or what 400 meters square to what 400 meters square they're coming and going to allow them to make some decisions on what they're going to do. This is a platform that's customized for each particular geographic location, and it's available in Canada as well as the US.
Good, wonderful. Thank you very much, Bob.
You are very welcome. Thank you, everybody.
Next up is Victor Darias, who is the Vice President of Strategic Sales for Global Traffic Technologies. During his time at GTT, Victor has worked with many agencies across North America, providing solutions to fit their niche, such as the New York City Transit, Montreal, and several others. Prior to his position at GTT, Victor worked in the telecommunications industry with companies such as Cisco Systems in Australia, managing global network providers and government agencies. Victor started with GTT in 2010 in the transportation space, including transit and emergency services, and has continued to work with strategic customers since the GTT acquisition. Victor attended Queensland University and studied business and economics. And with that, I am making Victor the panelist.
Okay, let me see. Display mode, show my screen. Okay, let me see, do you see the display mode?
Yes, I do. Thank you.
Excellent. Well, thank you very much for the opportunity to participate. Is your city ready for what's next? With how much uncertainty the future holds, city leaders worldwide need a tool like Opticom that can adapt to new laws, changing public health circumstances, and more. Today, I will be discussing the evolution of priority management request and how global traffic technology has been working to support the public sector in the past and during this current pandemic. Priority request is no longer just about changing the light screen for emergency vehicles or keeping buses on schedule. Cities are under a lot of pressure to keep up with the population growth and demographic changes and challenges. In 1990, Shanghai had a population of 13 million. Fast forward to today, the population of Shanghai is 27 million. That means their population more than doubled in the past 3 decades alone. Going green, adjusting to new standards, bringing legacy systems to the 20th century is a real challenge for cities. So the question becomes, how do you bridge from the past to the future? Some of the biggest challenges faced by cities and agencies are keeping up with demands from the current constituents, mayors, and rapidly emerging technologies, such as autonomous vehicles, data analytics, rideshare, and several others. GTT technology now allows cities to manage multiple agencies, including transit, fire, ambulances, snowplow, freight, police, and several others, by enabling multiple ways of requesting a green light. For example, transit agencies are able to request a priority not only by the lateness, but by a combination of multiple factors, such as schedule, number of passengers, time of day, directions. Our Smart City platform has been evolving to enable and empower cities and agencies to adapt to various changes, from technology transition and reduction of traffic, as well as supporting cities with current challenges. No longer is just processing a request and providing a green light sufficient. Governing in today's complex time requires cities and agencies to make smarter decisions to address environmental, safety, transportation, and taxpayers' concerns. Cities such as Montreal have dealt with the pandemic by transforming buses into mobile clinics to provide additional testing for COVID-19. The GTT Smart City centralized solution deployed in Montreal can support this initiative by enabling said buses to change their existing priority level remotely and in real time, depending on the day, direction of travel, or purpose. These actions would allow these temporarily mobile clinics to travel quickly and safely through clear intersections while minimizing disruption to your city traffic patterns. For example, traffic congestion in a city is often caused by double parked vehicles and truck uploading or unloading their goods. Our solution would allow cities to arrange for trucks to deliver their goods outside of normal rush hours, thus reducing congestion during peak traffic times and lowering green gas emissions. The definition of priorities is based on circumstances. With Opticom, you have flexibility, incident-based priority. Now the same rules that exist for law enforcement and emergency vehicle can exist for buses and hearse and other types of vehicles. So even buses can behave like emergency vehicles in this pandemic. If nothing else, the COVID-19 crisis has demonstrated the need for governmental flexibility. Priorities must be able to change with the times. Opticom offers new levels of flexibility to priority control. An incident-based policy is only as valuable to you as the ability to be flexible and change. Law enforcement requirements are different, so the request must accommodate the different types of requests that city traffic departments will support and won't impact the traffic signal timing or cause further impact. Traditionally, priority was only requested by engaging light bars and sirens. But now local agencies can set their own rules that dictate the specific circumstances under which priority can be requested. And most importantly, they can change that priority list to respond to changes in law, public health emergency, and several others. If you were to implement the same rules currently available for preemption on a fire truck to a police vehicle, there's a great chance the city would not allow a police vehicle to get preemption, as it would impact the synchronization of traffic signals. But if you're able to set the preemption by usage policy, you could customize the priority per policy. So one of our new initiatives working with law enforcement in the US has been setting up different priority levels. For example, you can have 5 or 6 different priorities. Priority number 1 could be a shooting, a kidnapping in progress, active shooter, or it can even be a robbery, a fire, criminal assault. You could pre-program the system to grant the priority on those levels. But if you had a priority for law enforcement that is animal complaint, criminal mischief, or loss of property, you could program the system to not accept those requests, those priority 3 to 4 or 5, or any other priorities. And that can be set by time of day and direction. One of the biggest challenges for cities and agencies is the ability to meet demand or changes set by mayors and other government officials. Leveraging existing infrastructure while at the same time transitioning to the new smart city requirements is a challenge. It's very challenging for cities and agencies to rip and replace in a very short period of time hardware at the intersection to meet new demands and standards, especially if you have cities with an existing infrared infrastructure used by the emergency department, a transit agency that wishes to migrate to a software solution or an API, another adjacent agency equipped with GPS radio-based priority request solution. In parallel, the City Traffic and Operation Department are migrating to existing infrastructure to a centralized ATMS capable management center or deploying comms to all their intersections. For the last 50 years, GTT has been working with several cities and agencies in providing priority request technologies while listening to their foreseeable challenges. Every new platform we develop is backwards compatible with the ability to coexist with the Opticom IR GPS radio-based solution and our centralized smart city hosted solution, enabling cities and agencies to transition and upgrade at their own pace. In this chart, you can see we could have any agency currently communicating with our standard hardware, infrared, to the intersection through a phase selector. But if they had a cell communication or a modem with GPS, it could communicate directly to the cloud. The cloud would go to the ATMS, leverage the current investment they've made, and communicate directly to the controller, hence removing any hardware, the traffic signal from GTT. This is being used in New York City and Montreal. And while the vehicle would travel to an adjacent city who may have a GPS-based solution or infrared, it could still communicate transparently between a centralized software-based solution, cell-based, to a distributed system or infrared system. So this empowers the city to plan their migration path, the transition, while still enabling other agencies to coexist and work and still get priority requests. In summary, GTT is supporting cities worldwide during the COVID-19 pandemic by enabling new features on our Smart City platform. We are partnering with third parties to provide a complete solution to cities and agencies. This pandemic has underscored the need for city leaders to have flexible solutions at their disposal. GTT is focusing its energy on following the standards to equip traffic managers to support city leaders and their strategies. Opticom offers flexible deployment and priority level to empower city leaders to tailor this solution to meet their unique local needs, such as temporarily changing priority levels for buses and other during this time of social distancing. Thank you very much. If you have any questions, please feel free.
Thank you, Victor. Got a question. You talk about in your last slide about city leaders to have flexible solution at their disposal. But I also guess it goes hand in hand with teamwork as well, right? Because if there's no team, then you can have the best flexible solution. So have you had any experience where, you know, there might be flexible solutions, but not necessarily that there's teamwork in order to make this happen?
Yeah, we've been identifying cities such as New York, Montreal, the region of York and Ontario, and others. There's been a lot of team collaboration between the city's DOTs and traffic department and their customers, the agencies. And that's been changing in the last several years. And we see a lot more teaming and collaboration and understanding each other's needs more and more.
Good.
Does that
Thank
answer your
you.
question?
Yeah, you talked a little bit about the about some of the standard hardware. So with social distancing in place or physical distancing in place, what are some of the best practices that you have put in place to maintain safety for those technicians who have to service hardware if there's any malfunctioning, for example, during COVID-19?
Yeah, we work closely with our dealers and the city's officials. We're across the US and Canada, so we must follow the rules implemented by those cities. So in the case that there's a traditional hardware of ours that is damaged or replaced, we collaborate with the city to identify when is a good time to go out there and replace it or send a technician out there so we can keep our social distancing. All of our team are working remotely, and we do have a schedule in place for our developers and engineers to go to the office and do some testing on certain schedule. All this not to impact our customers. From a software intelligence perspective, any city that has our Opticom system with IP communication to our central management software platform, they can pre-program, reprogram, or adapt remotely from their desktop. As long as they have access to the server. And the server can be located on their premises, or some of them are located on the AWS Amazon cloud. So we have fire departments like in Texas, Harris County, they do everything remotely. It's all provided by GTT. So we're able to manage proactively if there's any issues with the fire department and other emergency vehicles attending an emergency. So there's no, we can keep the distance between the cities and their officials in that environment.
Good. Thank you very much. Those were the questions that I had.
Thank you once again.
So with that, you're most welcome. So with that, I'd like to thank François, Anita, Masoud, Bob, and Victor. I would like to thank all of those who attended today's webinar. Our next webinar is coming up May 20th, 2020. I want to wish all of you to enjoy the Victoria Day weekend coming up. Please remember that the ITS Canada Awards virtual celebration takes place on June 15th, 2020. And today's webinar recording will be made available on the ITS Canada website tomorrow. Thank you all, and have a great afternoon.